Good morning, students. In the last video, we have discussed the major components of FES, their principles, and how they are going to work in the FES. Now, in this video, we will see the actual application of FES, how the FES can be used for quantitative analysis of unknown sample. It's also called as a method of quantification. Generally, there are three methods are used for the quantification in the instrumental analysis. In all instrumental analysis, the first is calibration curve method, second is standard addition method, and third is internal standard method. Now let us discuss the calibration curve method in detail. So first step is to prepare a series of standard solution. The standard solution is the solution whose concentration is known. Now in the second step, aspirate each standard solution in the flame and measure the emitted intensity for each standard solution. Step 3, plot a graph of concentration against the flame intensity. Such a graph is called as a calibration curve, which is further utilized to find out the concentration of the sample solution. Fourth step, the nature of the graph is a straight line passing through the origin as shown in the figure. So in the figure we can see a graph which passes through the origin. Step 5, aspirate the sample solution into the flame, measure the flame intensity for the sample. And step 6, with the help of calibration curve and the flame intensity of the sample, find out the concentration of the sample as shown in the figure. So with the red dotted line, we can see how the calibration curve can be used for the detection of the concentration of unknown. The next method is the standard addition method. Now let us discuss the standard addition method in detail. In this, increasing volume of standard solution is added to a fixed volume of unknown solution. Try to understand again. In this, increasing volume of standard solution, not increasing concentration of sample solution, standard solution is added. Increasing volume of standard solution is added to the fixed volume of unknown solution. If S is the concentration of the standard solution and X is the volume of the unknown solution, then series of solution will become X, then X plus 1S, X plus 2S, X plus 3S, X plus 4S, so on. In this we can see the volume of the sample or unknown solution is constant, while volume of the standard solution goes on increasing. In the first, there is no standard solution. In second, 1S standard solution. In the third, 2S standard solution. In fourth, 3S standard solution, and so on. This series of standard solution are aspirated into the flame and the intensity is measured. Also, the intensity of unknown is measured. This intensity is plotted against the x, then x plus 1s, x plus 2s, and so on. So we get the graph as shown in the figure. Okay, this graph is not going to pass through the origin, but it is going to have intercept on the y-axis as shown. Okay. So this graph we have to extrapolate so that it will cut the x-axis, which is shown by the dotted line, and that will give us the concentration of the unknown. Note, in this method, correction is made by subtracting the background signal. Now, how we are going to calculate the background signal? For this, solvent is used for preparing the sample in the flame and its intensity is measured. This intensity is subtracted from the intensity of standard and sample. And third is the internal addition method. Now, internal addition method or internal standard method, internal substance is added. Now, what is the internal substance? Internal substance is the material which is having similar chemical property as that of sample and should not be present in the matrix of the sample. Such a substance is added in the standard, blank and the sample. Remember, again, I will repeat, the internal standard or internal substance which is having similar property to that of sample is added to standard, sample and as well in the bag. Okay, standard is shown by S and sample is shown by X. Now emission intensity of internal standard. Okay, then internal standard plus sample, that is E S X, and internal standard plus standard is measured. EA is measured. Now step third is very important. The ratio of EA to EI and EA to EIX is find out. Okay. Now the graph of EA to EI against the concentration of standard is plotted. We get the straight line passing through the origin. Then with the help of EA to EIX, that is for sample, by using that value, we can find out the concentration of the unknown. With the help of graph and the value of EA to EIX, the concentration of unknown is found out. So application of FES. So let us discuss the application of FES. First application. This method is mostly applied to the alkali and alkaline earth metal because the trace analysis of these elements with other method is not possible or rather difficult. The study of electrolyte balance in the physiology and clinical analysis can be done by using FES. Then the determination of lead in petrol can be easily done with the FES. It is used to determine the calcium and magnesium in the cement, and it is also used to study the equilibrium constant including ion exchange resin is also possible with it. Now let us discuss some of the limitations of APS. This APS gives us the total metal content in the sample and does not give any information about the molecular condition of the metal in the sample. Second, non-radiating element like carbon, sulfur, hydrogen, etc. cannot be detected for this indirect method is used. Only liquid sample can be analyzed. Two elements emit the same wavelength interfere in the analysis. For example, the Fe emits the radiation 285.213 nanometer and magnesium emits 285.212 nanometer. Such a element are going to interfere in the analysis of each other. Such interference can be removed by separating these two elements by separating methods. The element having low ionization potential reduces the emitted intensity and causes the error in the analysis. So with this, we end this slide or end this discussion. Here we complete the total discussion of APS. If you come across any sort of difficulty, without hesitation, you can contact me and you can talk to me. Till then, goodbye. Definitely in the next topic, we'll discuss the atomic absorption spectroscopy. Till then, goodbye.